everybody. So we're going to start off with a question. Who here is familiar with atomic design? All right, quite a few hands. That makes me happy. I'm going to go through it real quick just in case you don't know. Conceptually, it's pretty simple, but I'm going to start off with a mantra that served the software engineering community pretty well. That's that you should never throw away your code and just start over from scratch. And as far as I could tell, that this was made famous by Joel Spolsky in his seminal Things That You Should Never Do, Part 1. Now, this article has stood up amazingly well since 2000, and it's because that building something from scratch is not advised unless you've got a really good reason to do it. And there's some things about this article that kind of bug me a little bit. It was written a little bit before the dot-com bubble. It's been around for 17 years, and the way that you could describe the startup climate at that time is it was chaotic. If you were a leader in just about any space, there were likely several startups right behind you. Think the search engine wars. But I think that the idea that we should never rewrite gets a little less true over time. And the older code bases get, the more unwieldy they get. And maybe you can keep ahead of your tech debt, and you can push this back forever. Or maybe you end up piling up your technical debt, and you get into a situation like this. So this is what happened to the buffer code base as we added more engineers over a period of 5 years. So the commits per individual decreased. And as each person joined, everyone else became less effective, less productive. And this happens because of good old-fashioned tech debt. But it also happens because as you increase the team size working in a shared space, you increase the complexity and overhead as everyone else's work is tangled up in everybody else's. So if you recognize this behavior and you recognize this graph, this talks for you. So let's talk a little bit about the mythical rewrite. And this is the point where companies face the death choice. That's to stop and rewrite. You're going to freeze feature development, or maybe you're going to build everything twice in 2 separate repositories. Some people are familiar with the Basecamp story where they actually did this successfully. But that's not the case for everyone. So less people hear those stories about the rewrite because they never lived to tell it. So that leaves us with the other option, which you keep hacking away, you make minor adjustments, maybe add some tests, and you walk down this declining marginal productivity curve. And you add more engineers just to make things happen, and as you add more people, it just keeps getting slower and slower. So this looks like like a slow death. And a lot of those companies, you hear the stories where we didn't stay agile. We couldn't keep up. We just stopped innovating. And a lot of us have been here. A lot of us are currently here right now. And Buffer got into this spot because our stack isn't very amenable to change. And most importantly, we weren't writing code that could handle change well. So now all of our options don't feel like good ones. But there's actually another option. We can do an asynchronous rewrite, where we move to an architecture that's better at handling change. And this is where atomic design can help us out. So what is atomic design? In a nutshell, it's where you build complexity by stitching simple things together. You have a concept of atoms, and then expanding a little more complex, you have molecules and organisms. It kind of borrows from the perspective of the outside world. So atoms are things like labels, inputs, buttons. These things work in a lot of different contexts. They're highly reusable, but they're not very useful in and of themselves. We need to start putting them together as molecules to start building functionality. These are things that still work in a number of contexts, but they've been designed for a very specific task. And I've got an example of a search component, and it combines those atoms together. Now, if we increase complexity a little more, we can combine those atoms and molecules, and we can stitch those things together. And this is where you start to set things like context, and where you define your business logic. And what I mean here by context is that's the state of your application. Whether this is stored back-end, front-end, that's kind of up to your architecture. And what I mean by business logic here is a set of operations that you can use to manipulate the state. So an organism is something that's useful on its own, and this is something that you could put in front of a customer. So if you're familiar with atomic design, which many of you are, there's also a template and a page in this concept. But I don't think these things are quite as useful when you're working with single-page applications. And this is typically because a lot of single-page applications only have a couple screens in which the atoms and molecules are stitched together. It's also the case that in many frameworks, like React, for instance, many of your atoms and molecules can be implemented as templates anyways, so it sort of breaks the metaphor. But if you're building things like marketing sites or blogs with lots of different pages, with different structures, these things are still useful. So I'd like to share a little bit how we've gone through our migration journey at Buffer. So very first, step one. That was a React storybook slide, but anyways, basically all you do is you create a space that you can start developing your atoms. This is where you capture the essence of your developer environment. And we chose tools like React Storybook and Just Snapshots. Now, molecules are this is the same kind of idea. You're just creating a space where you can develop your molecules, and you're building slightly more complex things. So the very first step that you do towards taking action is you pick something in your application, something really small, something like text. And you build out that text in your atom library. And then you can replace one of those text elements within your application. And the reason why you start with something like text is because it's simple. It doesn't require a lot of user interaction. It allows you to focus on things like how do you actually get your atoms and your atom into your application. For us, that was NPM. And then you deploy it, and if no one notices, that's a success. So from here, now you pick a new feature to start building out your next more complex piece. You start building your molecule. Maybe this is the very next thing you're working on. Maybe you're working on several things, and it's a low priority thing that's not in front of a lot of customers. It kind of depends on your business and your needs. But the first thing you do there is you start breaking that down into atoms. And you can see there's some reusable components here. We've got some texts, we've got some images, we've got some buttons. You can imagine that these could be useful in other parts of the application as well. So after that, you implement all of your atoms within your atom library. And then you start bringing those atoms into your molecule library. For us, again, that was NPM. And after that, you can take, oh man, there was a Voltron GIF here. Anyways, so you start assembling your molecule in your application. You set the context there. The very first approach that we tried was to use iframes. And we were particularly worried about guarding against CSS. 5 years of CSS development, there's definitely some pretty hairy things in the code base. And we wanted to be able to mitigate some of those things without a lot of work. But as we went deeper down that approach, we started to use post message more and more. We were doing things like showing and hiding overlays outside of the parent iframe, and triggering UI updates on the parent. And the final thing that stopped this approach was we wanted to utilize some of the existing resources, particularly WebSockets. We were faced with a pretty tough choice. We could create another WebSocket and have twice as many WebSocket connections, which WebSockets are hard to scale to begin with. Or we could implement a bridge that could allow us to utilize the parent WebSocket, but do all the message passing over post message. Neither of these things felt like a good option for us. So we tried another approach. All of our atoms and our molecules are implemented with inline styles. And then at the very highest level where we bring our feature in, we set a reset class that allows us to undo all of the things that have been set on the global scope. And the reason why this works is because inline styles are more specific than the rules that we use to unset the CSS. So our atoms and our molecules in our application end up winning. So now we can utilize any piece of the code base that we want, which is really nice when you're migrating from a legacy application. And we could, most importantly, utilize WebSockets and not have to duplicate those things. So the final phase is to build your new application shell. This is where you start building a home for your new atoms and molecules. And the pattern looks like this. New features are shipped within your existing application. And then you take those same components and you bring them into your new application. And you build the navigation elements and set the context for those pieces as well. So you're not rewriting everything, just the navigation pieces. And you iterate in this way where you're bringing features in little by little over time until you can start migrating some of your customers over there. And once you've migrated all of your customers onto that new application, then you're done. So what does this look like from the developer's perspective? Well, we want to capture the most productive environment for developers that we can. That's to say, it should be faster to get work done locally than in production. I shouldn't be changing PHP. I shouldn't be changing JavaScript on my production servers. Very bad things can happen there. And developers should be able to use whatever the most effective tools are right now. And that's going to change over time. For us, that's using tools like React Storybook and Just Snapshots. But those things are probably going to change, and they might even be different based off of your stack, what skill sets you have in your organization. But they capture some things that I don't think are going to change over time. And that's when you're building UI, building in an isolated environment happens to be more productive than building within the context of your entire application. Another thing is they allow you to build the API of your components first. So you can, it's almost like TDD, where you can think about what you're going to build, and because you've thought through the whole thing, you end up with a more complete, simple piece of UI. And also, they allow you to think about state last, if at all. So these things, if you put them on all of your projects, they also allow developers to be using the same tools across all of your projects. So it's easier for team members to move from project to project based off of their interests. So I want to leave you with this last slide. Build for a changing future. We're here because JS is in our lives for one reason or another. It's something that's constantly changing. It's getting better. It's getting different. And so is all the tooling around it. So it's very likely that we're going to be writing code today that tomorrow is going to be rewritten because something changed that makes sense to move toward it. So if you're going to do a rewrite, do it while continuously shipping features, and do it modularly. So I just want to say thanks, everybody, and it's been a pleasure to be up here.
So whenever I see a talk start with a Joel Spolsky post, and full disclosure, I work at Fog Creek, I always kind of get like nervous because I'm like, he writes great stuff, but sometimes I feel like some blogs of anybody's writing should be ephemerals, but this is like one thing where even though the blog post is literally 17 years old, actually like holds true, but I feel like a lot of people aren't really following that sort of advice, which is kind of frustrating. So it's really nice to see a buffer like this being like in practice, and it's really great to see sort of a pragmatic approach to handling a very overwhelming, venture, which we ourselves are going through.
Right on.
And I love React Storybook. I had worked on a project with it back when I was consulting, and I don't know if this is the case at Buffer, but it felt like it allowed to get everyone in the company involved in the process, designers and then developers of different levels. So was that the case, like with you working on Atomic Design? Like, did you have designers and maybe junior developers and stuff working in tandem on this?
Absolutely. we actually had several meetings with designers where the initial design that we got, we were able to test it out with them, and we found a bunch of accessibility bugs using Storybook before we shipped them out to customers. So iterating on those things there was actually really awesome.
Yeah, that's awesome. Yeah, I can recommend React Storybook enough, especially for the accessibility testing. Did you find that, did you encounter any issues with releasing different pieces in terms of like messing up with the rest of your code, or did you find that you just had to like write a lot more tests in order to prevent that from happening? Because I think that's one thing that people are afraid of, is like you have an app that works, and if you add one little component, like an avalanche of garbage happens.
So we're still perfecting that. That is something that we're worried about as well. I can't remember the tool, but there's something that allows you to grab a snapshot of all your rendered components and does a visual diff. We're playing with that. Oh, it's Percy. Percy has a new React plugin, and I think that might actually help because it shows you every change. So if you change one little component, it'll show you everywhere it changed in your application.
Cool. Now, in terms of workflow process, I find that when working on a large project piece by piece, I like to feel like success points or like milestones. Like, how do you set that up where you feel like you've accomplished something even though the whole thing hasn't been rewritten yet?
So we, at Buffer, we're using, we're kind of following Basecamp's steps with using 6-week cycles. We actually just did our first 6-week cycle where we picked a feature and we said, this is our goal for the next 6 weeks. And everybody on the team has been moving towards that. And that's been small enough that we've been able to go, everybody was excited when we finished the next one, isn't excited for the next 6-week cycle. So yeah, every 6 weeks we have a new point where we keep meeting.
That's cool. Yeah, I like the celebration moment, so it's important to work that in. Well, thank you very much, and good luck with the rest of your cycles. And
thank you very
look
much.
forward to see Buffer the same.
Thank you.